This is the mock final exam solution for Math 10 first semester. First page is about linear inequalities. The first problem is like a one-dimensional problem. It's a number line problem. Then the second problem is like a two-dimensional problem. It's a Cartesian plane. So you notice that the second problem has x's and y's in it, and the first problem has just one variable, which happens to be t in it. Okay? So both of them have absolute values, and that's about as hard as it gets. So let's figure out how to do these. Okay, so the first thing we're going to do is we're going to look at this inequality here. And what we want to do is we want to, and there's more than one way to do it, but this is the way I think is the easiest way to do it. We want to isolate the part that is in the absolute value. Put it all by itself on one side of the equation. So we're going to do algebra until this green part is all by itself. First thing we're going to do is we're going to do the outermost operation here, which according to PEMDAS is the -7, right? So algebra is like an onion. It always makes you cry. Just kidding. So like if algebra is like an onion because you can start with the center of the onion and then you put on the second layer of the onion, which is multiplied by -2, and then finally the last layer of onion, which is subtract 7. So you're going to unpeel the onion one layer at a time, and the layer that you're going to unpeel first is the -7. So how do you undo -7? You're going to add 7. So we're going to add 7 to both sides, right? So I'm going to add 7 to the right side, add 7 to the left side. And what I get is -90 on the left side, and then in the middle I have -2 absolute value 3t plus 225, and then my -7 is now gone. Okay? Now what's the next layer to unpeel? The next layer to unpeel is this multiply by -2. Some people might think it's subtract 2 because there's a minus sign there, but actually that's a negative sign. And so how do we get rid of a multiply by -2? Well, we divide by -2. So I'm going to divide both sides by -2. The left side is going to become positive 45, and the right side is going to become just the absolute value, 3t plus 225. Now there's something that's tricky that happens here, and the reason why is because we divided by a negative number. Whenever you divide by a negative number, something happens to an inequality. Nothing happens to an equality, but if you have if I have 1 is less than 2, and then I divide both sides by -1, what's going to happen? I'm going to end up with -1 is less than -2, which is not true, right? So in order to make the inequality continue to be true, whenever you divide by a negative number or multiply by a negative number, you do have to invert the inequality sign. So if it was pointing to the left, now it's pointing to the right. Okay? So that's what we need to do here. We need to invert the inequality. So now instead of being less than, now it's going to be greater than. Okay? Now what we're going to do is we're going to look at the absolute value sign, and we're going to say, okay, there's two cases for this absolute value sign. Sometimes this absolute value sign doesn't do anything because the inside is positive, and sometimes the absolute value sign makes everything negative because what's inside turns out to be negative. Okay, so let's say that t was 1,000. If t was 1,000, obviously the inside of this is going to be positive, and then the absolute value sign is not going to do anything. Okay, so let's do that case first. So when t is really big, then we'll just have 45 is greater than 3t plus 225 without that absolute value signs because nothing happens, okay, when the absolute value sign is there. And then the other case is when, let's say that you put like -1,000 in there. If you put -1,000 here, then the inside is going to be a negative number, and the absolute values act like a negative sign. And so we're going to write an equation for that case too. So we're going to -3t plus 225. Okay. All right, so there's these two cases, and each one is separate, so we're going to solve them separately. First, we're going to have 45 minus 225. 45 minus 225 is going to be, it's going to be -180, right? So -180 is greater than 3t. All I did was I subtracted 225 from both sides. Now I'm going to divide 3 from both sides. I'm going to end up with -60 is greater than t. Okay, so that is half of my solution. The other half of the solution is over here. I got 45 is greater than negative 3t plus 225. First thing I'm going to do is I'm going to distribute the negative sign. Okay, so like for example, I got the negative here. I'm going to multiply it times 3, and I'm going to multiply it times the 225, and then I can get rid of the parentheses. So I'm going to have 45 is greater than negative 3t minus 225. Now I'm going to add 225 to both sides. And I'm going to get 225 plus 45 is going to be 270 is greater than negative 3t. Now I'm going to divide both sides by negative 3. And when I do that, I need to invert the inequality again. Okay? And so I'm going to divide both sides by negative 3. And on the left side, I'm going to have negative 90. And on the right side, I'm going to have less than t. Okay, so now I have these two statements, and I'm going to draw them out on the number line. So t is less than negative 60 means that I'm going to put an open circle around negative 60, and I'm going to shade to the left because t is less than negative 60. Then I have t is greater than negative 90. So t is greater than negative 90. I would put an open circle on negative 90 because it's less than, t is greater than negative 90. It's not t is greater than or equal to negative 90, so I put an open circle, and then I shade to the right. And you can see that these two areas kind of merge, and the region that is true for both happens to be between these two open circles. So that's my solution. All right, moving down to the two-dimensional problem. Solve the system of inequalities by graphing. Okay, so there's two equations here, and we need to graph each one separately. Okay, so let's do the easy one first, the one that doesn't have an absolute value in it. And it's always easier to graph your equation if it's in what we call slope-intercept form, right? So let's try to put this in slope-intercept form, and if we do that, then I think it's easier to draw it on the grid. So we need to get y by itself on the left side. So to do that, I'm going to subtract x from the left side. I'm going to subtract x from the right side. I'm going to get 2y is greater than or equal to minus x minus 10. Okay, I'm almost in this format now. Now, to get it completely in this format, I'm going to divide both sides by 2. If I do that, then I'm going to have y is greater than or equal to negative x divided by 2 minus 10. Divided by 2. Okay. Finally, I'm going to simplify one more step. So I'm going to have y is greater than or equal to negative 1/2 x. Negative 1/2 x because negative x divided by 2 is the same as negative 1/2 times x, right? So our slope happens to be negative 1/2. Minus 10 over 2 is equal to minus 5. So our y-intercept is negative 5. Okay? All right, so that's one of our equations. The other equation is going to be from this here, and it's already kind of in slope-intercept form, but we need to break it into two parts because it has an absolute value. And if you have an absolute value, just like in the first case, remember how we divided it into two different cases? The case where the absolute value does nothing and the case where the absolute value makes everything negative. So we're going to do that here. And again, what we need to do is we need to first isolate the absolute value by itself. So even though we're already in slope-intercept form, actually we need to reverse everything and put everything on the left side except for the absolute value on the right side. So we're going to do that. We're going to have y minus 4 is less than or equal to absolute value of 6x. And then this absolute value of 6x, there's two cases. There's a case where the absolute value does nothing when x happens to be positive. And in that case, we'll have this, where the absolute value does nothing. And then we'll also have the case where the absolute value makes everything inverted, which it's going to be negative 6x. The absolute value is going to act like a negative sign. Okay? So now let's put both of these equations into slope-intercept form, because that makes it easier to graph. So now I'm going to put the 4 back on the right side. So I'm going to have y is less than or equal to 6x plus 4. And this other one, I'm going to have y is less than or equal to negative 6x plus 4. So I just moved the 4 back to the other side. Now I have these two equations, which I'm going to graph. So I got this equation, I got this equation, this equation. I'm going to graph them all on the grid here. Okay, so first I'm going to do this y is greater than or equal to negative 1/2 x minus 5. So in this one, the y-intercept is minus 5, negative 5. And, oops, that's not negative 5. This is negative 5. And then the slope is negative 1/2. Negative 1/2 is a downward slope because it's negative, right? And the rise happens to be 1, or negative 1, and the run happens to be 2. So basically, it's like goes down 1 and over 2, like that, okay? But it's going to intersect here at negative 5, so that means it's looks kind of like this, okay? And it's greater than or equal to this line, so that means it's, oops. That means that it's the numbers that are above this line, right? Y is greater than or equal to this line. Okay? All right. Another way you can do it is you could say, oh, is 0, 0 part of the shaded region? And you put 0 in both. You put 0 in the x, you put 0 in the y, and then you see if it's true. Is 0 greater than or equal to 0 minus 5? Is 0 greater than or equal to negative 5? Yes, it is. So that means that the origin 0, 0 is in the shaded region, so we can shade above the line. Does it include the line? Yes, it does, because it's greater than or equal to the line, so we can draw a solid line instead of a dotted line. Okay? All right, now let's do this one. 6x plus 4. 6x plus 4 is right. It intersects the y-intercept of 4, and it goes up at 6 over 1. That means that the rise is 6 and the run is 1. So that means it goes up very steeply like that, right? And then we also have one that says y is less than or equal to negative 6x plus 4. In this case, again, the y-intercept is 4, but now it's a downward slope of negative 6 divided by 1. So the rise is negative 6 and the run is 1. So it goes down 6 and over 1. Okay. Now, in both cases, we're talking about y is less than or equal to 6x plus 4, and y is less than or equal to negative 6x plus 4. So our lines are not dotted, they're solid lines, and we're going to shade the regions that are below the lines. Okay? All right. So, one more thing I want to confirm is, here, when I say, oh, in this case, we don't do anything. We don't, the absolute value does not make it negative. What case is this? That is when x is a positive number. So in this case here, it's when x is positive. And then in this case here, it's when x is negative, right? Because if x was a negative number, then there would be a negative number inside the absolute value. The absolute value would be the opposite, and it would take effect with the negative sign. Okay, so now let's make sure that we did everything correctly. So since here it says x is greater than 0, it's going to be this line, 6x plus 4. Let's see, x is greater than here, is greater than 0 is this region, and the 6x plus 4 line is this line here. So that's right, okay? And then this part here, x is less than 0, would be this part, and which line takes effect? It's the negative 6x plus 4 line, so that would be this one here. And then we're going to be below those two lines like that. Okay? So the whole region, if we're gonna consider both regions to be true, then it would be basically this whole region here that's shaded. Okay? All right.